Hello children, welcome to my channel. Let us now start our class, that is 10th class real numbers topic. And before going to that, a small problem for you. What is that? Fortune favors the bold. What is fortune, children? Fortune means good luck. Good luck means what? When we say that I'm lucky enough, when you get what you wanted, then you say that yes, I'm lucky enough to have it. So that fortune will not occur just like that, children. All those people who have acquired their wishes, you can say that they are very lucky, so they got it. But if you observe their way of life, you will understand that for getting that fortune to them, they might have toiled their life a lot. Toiled means they worked hard, very hard. And how you know? Sometimes they may even feel that it might not be possible. Even in that situation, they might have been, or they were very bold. Why don't I do? I should do it. And they did it. So they got the fortune. So bold people only, those who are bold enough to face the situations, to overcome the problems, for them only the fortune favors children. Okay, now let us come back to our topic. We are doing real numbers, exercise 1.1. In the previous video, I have taught only one problem, that is fourth problem, because it's a very big problem. I have taken total time for that solving that problem. Now we are having the fifth one. Show that one and only one out of n plus 2, n plus 4 is divisible by 3. Means either n or n plus 2 or n plus 4. Out of these three, only one is divisible by 3. This is what is given. So let us start the topic with Euclid's rule. What does the Euclid's rule says, children? A is equal to BQ plus R, where 0 less than equal to R less than B. Now in this case, in this problem, according to problem, A value should be taken as n, children, and B value should be taken as 3, because in the problem they said that it is divisible by 3. B value should be taken as 3. What does this implies? R is equal to 0, 1, 2. Now, what are the values they have given? A is equal to either n, or A is equal to n plus 2, or A is equal to n plus 4. We have to write n plus 2 and n plus 4. Any one you have to take A. So let us suppose first one, remainder is 0, 1, 2. So first if R is equal to 0, then our formula A is equal to BQ plus R. That means n is equal to 3q plus 0. That means n is equal to 3q. It is multiple of 3, children. Therefore, what we will say? 3 divides n. Suppose. See, you have taken n here. Now let us take n plus 2. N plus 2 means 3q plus 2. Now 3q plus 2, can you take any value as common? You cannot take. You know that 3q plus 2 is not divisible. It is not divisible by 3. N plus 2 is not divisible by 3. Now you take n plus 4. What is n plus 4, children? N is 3q. Okay, and then n plus 1, n plus 2 and n plus 4. 3q plus 4. Can you take 3 as common? You cannot. So it is also not divisible by 3. So in all the 3 cases, which is divisible, children? N is divisible. So we will say that only, therefore, here I will write, therefore, only n is divisible by 3. Where when you have taken n value, r value as 0, children. When you have taken r value as 0, we got that only n is divisible by n value. He is asking either n or n plus 2 or n plus 3. Out of 3, only 1 is divisible by 3. So in this case, we have got only n is divisible by 3. You copy this, children? Now, if r is equal to 1. Now, let us see. If r is equal to 1, then a is equal to pq plus 1. That means n is equal to 3q plus 1. n is equal to 3q plus 1 is not divisible by 3. Now, we go for n plus 1. What is n plus 1? N value you got 3q plus 1 and n plus 2, sorry, you have got n plus 2. n plus 2 means n is 3q plus 2 plus 1, n value is 3q plus 1 and add 2 to it. We are getting 3q plus 3. Means I can take out 3 as common, q plus 1. So since I could take out 3, 3 divides n plus 2. So in this case only n plus 3 is divided by n plus 2 is divided by 3. But what about n? N is not. Now when you go to n plus 4, n is 3q plus 1 plus 4. How much you are getting? You are getting it as 3q plus 5. It is not divisible by 3. So in this case, what are you getting, children? In this case, out of n plus 2, n plus 4, only n plus 2 is divisible by 3. So n plus 1, n plus 2. So we have got n is divisible by 3. Now we have got n plus 2 for only this is divisible by 3. Now let us go to n plus 4. For that you just copy this. Now we have got the next one, r value. I have finished r is equal to 0. I have done r is equal to 1, r is equal to 2. If r is equal to 2, then a is equal to bq plus 2. That means n is equal to 3q plus 2. If n is 3q plus 2, can you say it is divisible by 3? No. So, it is not divisible by 3. Now, we go to n plus 1. What is n plus 1, children? N is equal to 3q plus 2 plus 1. Okay, we have to go for n plus 2, not 1. N plus 2. n plus 2 means 3 cube plus 1 plus 2. How much it is? 3 cube plus 4. It is not divisible by 3. So this is not divisible by 3, where n plus 2 is also not divisible by 3. Now go for n plus 4. What is n value? 3 cube plus 2. 3 cube plus 2, you are adding 4. You are getting 3 cube plus 6. Here 3 can be taken as common. Cube plus 2. So since 3 is common, it is. That means in the place of it, you can write, okay, we write here it is divisible by 3. So what are we going to get in all these things, children? Only n plus 4 is divisible by 3. So I hope you have followed, children. In this case, when a number is divisible by 3, the question is you have to show that one and only one out of n plus 2, n plus 4 is divisible by 3. In the first case where we have taken, since b is equal to 3, r is 0, 1, 2. When r is equal to 0, we got that it is divisible, n is divisible by 3. Remaining n plus 2, n plus 4 are not divisible by 3. Next, when we have gone for the r is equal to 1, we have got that n plus 1, n plus 2 is divisible by 3. Remaining n and n plus 4 are not divisible by 3. Next, when we go for n plus 4, we have understood that n plus 4 only, that means r is equal to 2 when you have taken, we got that only n plus 4 is divisible by 3. n and n plus 2 are not divisible by 3. I hope you have understood, children. You can copy this. Now with this, we have completed exercise 1.1. Exercise 1.1 in your textbook, first exercise, real numbers. I have completed, children. Now, let me go to fundamental theorem of arithmetic. You have got a theorem here, children. Theorem 1.2. It is fundamental theorem of arithmetic. This is the name of the theorem, children. I want you to note it down by saying in your textbook. Few points I will write and I will explain this. Every composite number. Every composite number. It goes on like this. Let me read and explain you this theorem, children. Every composite number can be expressed as a product of primes, and this factorization is unique, apart from the order in which the prime factors occur. That means what? Any composite number. You know about prime numbers and composite numbers, children? Prime numbers will be having the factors as 1 and the number itself. And composite numbers, all those which are having many factors, which are not prime. Of course, one is neither prime nor composite. These are all the basics which you have studied in your previous classes. So now, when I am talking about this composite number, if you take any composite number, it is possible for you to write the prime factorization. Let me take one example for writing that prime factorization of this. Suppose you have taken a number 136. I'm taking 136 and I'm writing prime factors. 2 6 are 12, 2 8 are 16. Again, 2 3s are 6, 2 4s are 8. Again, 2 1s are 2 7s are. So, 136 can be written as 2 into 2 into 2 into 17. If you write base and form, 2 cube. 2 3 times you are multiplying, 2 cube into 17. But the same one, you can do it with 136. Suppose there is another person who has taken 17 table and started. He knows 17 table pretty well. 17 8 are 136 he has taken. Then 2 4s are, then 2 2s are. So 136 can also be written as 17 into 2 into 2 into 2. That means 17 into 2 cube. In any case, you see children, the answers are 2 cube and 17 only. But only the thing is their order got changed. Why the order got changed? It is just because of the individual's efficiency or individual's ease with which they are doing the problem. Only the concept here is what? You have to take prime numbers. These values which you are taken should be prime numbers. Suppose if anybody takes composite number, he is definitely wrong. He will never get the answer. So, you are supposed to take only prime numbers. That you should keep it in mind. So, what does the theorem says? Once again, I will say, every composite number can be expressed as the product of primes. See, these all are primes. Primes. Every composite number can be expressed as the product of primes. And this factorization is unique. What is meant by unique? Unique means individual's facility or individual's way of doing problem. So it is unique in this way, it is unique in this way. Means every individual has can do it in their own way. Apart from the order in which the prime factorization occur. What is not uniqueness? Not uniqueness is order. Uniqueness is prime factors. Any way you do, you'll be getting the same prime factors. But the thing is what? Order is not same. Order does not follow the uniqueness because it depends upon the individuals which table they started, with which table they have started taking prime factorization. Accordingly, the answer changes. I hope you have understood, children. What you have to do is write this theorem completely in your classwork and you write example here. Take this as an example. This will give you a clear understanding about this theorem, fundamental theorem of arithmetic. I hope you have followed, children. Just copy. Now, we will go to the next topic. The next one is find HCF and LCM of 12 and 18. It is example 4. Example 3, you have one problem, children. But I want to teach this example 3 when you have got the same type of problem in the exercise. Because its procedure is a little bit different and a very easy sum it is actually. But if I teach that and go for this example 4, a little bit confusion may create in your minds. As I am doing with the prime factorizations, let me do the procedure properly so that it will fix into your mind. The process will fix into your mind properly. So I am going to with the example 4, children. Example 4. What is asked in this example 4? In this, they are asking to find HCF, highest common factor, and LCM. LCM means what? Lowest common multiple of 12 and 18 by, they are asking you to do it by prime factorization. By prime factorization method, children, remember carefully. You have got various methods to do this. Whatever method they have asked, you have to follow that. In the earlier case, we have done HCF. How? By using Euclid's division rule algorithm. So, in the problem, if they ask you to find HCF by using Euclid's division algorithm, you should do only that method. You cannot go for prime factorization method. If you go, since you have used another method, you may not get the marks for it. So, what is asked to you children? That is very important. Which method they have asked? You have to follow that method only. In this example, he is asking to find out what is HCF as well as LCM of two numbers they have given. By prime factorization method means you need to find out prime factors of each and every value that is given to you. So, you have got 12 and 18. So, let me take 12 and find out the prime factors. 2 6 are 12, 2 3s are 6. Anything else? I cannot go anything. So 12. How am I getting 12 value? By taking 2, multiplying it by 2 and 3. Now, let us take 18. Again, 2 9s are 18, 3 3s are 9. So, 18, you are getting it as 2 into 3 into 3. These are the prime factors. Now, you have to go for HCF, children. Before going to HCF, underline the common factors. Easiest method I am teaching you. Underline the common factors. In both 2 is there, so you underline. And in both 3 is there, so you underline. Whatever you have underlined, that instead of 2, you take once. 2 into 3. So HCF is 6, children. Understanding what I said? You take one number here. If you have same number anywhere, it does not need that should be below this number only. Anywhere, but you underline it. That underlining part will tell you that they are common. So again, 3 here, 3 here. These two are also common. Now I have taken HCF. Now if you are asked to find out LCM, see children, the easiest way what I am saying is this 2 and 3 you write. That means what you have done? Common values you have done. Now, what all the remaining numbers which you have not underlined, take that also. That means in this the leftover is 2 and in this the leftover is 3. You multiply all this. 2 3s are 6, 6 2s are 12, 12 3s are 36. So LCM is 36. So this is your answer for this problem, children. I hope you have understood. You have to go for the prime factorization. Write the prime factors like this. Underline the common ones. Out of 2, you write only 1 and multiply, that is HCF. When you are writing LCM, whatever factors you have written, you write that. And whatever remaining values which you have not underlined, that also you take and multiply, that will give you LCM. This is the easiest method I am teaching you, children. This will make you not to go any wrong in your exam. Okay? Please copy this. Next. Now, the next part here, you have do this problems, children. You have do these problems. First one is do this. First bit is 120 and 90. What is 120 and 90? LCM and HCF they have asked. Same. These problems are for LCM and HCF. So, take 120. 2 6 are 0. 2 3s are 0. 2 1s are 2 5s are and 2 1s are 2 5s are 3 5s are. So what is 120 means? 120 means 2 into 2 into 2 into 3 into 5. This is the value of LCM, prime factorization of 120. Now go for 90. 3 30s are, 3 10s are, 2 5s are. So 90, you are getting 3 into 3 into 2 into 5. Now underline. 1 2 is here, another 2 is here. Remaining 2 is no common, so we don't write. 1 3 is here, 1 3 is here. Again 5 and 5. These are the common ones. So by taking common ones, what is HCF, children? Out of 2 2s, we will take 1 2. Out of 2 3s, 1 3. Out of 2 5s, 1 5. How much, children? 5 2s are 10, 10 is 30. 30 is the HCF. Now go for LCM. 2 into 3 into 5. You have written into whatever you have not written. Here I have written not written 2 into 2. So I have not written. Then in the 90 I have not written 3. So I should multiply all this. This product is 30. I have already got 32s are 60. 62s are 120. 123s are 360. So LCM is 360, HCF is 30 is the answer for this problem. You can copy, children. Okay, now we will go to the second bit, 50 and 60. So 50, 5 10s are, 5 2s are. So how are you getting 50? 5 into 5 into 2. Next 60. 2 30s are, 2 15s are, then 3 5s are. So 60 what you are getting, children? 2 into 2 into 3 into 5. So common 5 is there. For another 5 nothing is there, only 2 is there here. You have anything common? Nothing else. Only that much. So what is, first we are doing HCF. HCF is 5 into 2, 10. What is LCM? Write 5 into 2 and in this remaining is 5 and here remaining is 2 into 3. So how much you will be getting? 10 10 are 100, 100 3s are 300. 300 is the LCM. This is the answer, children. You can write down this, note it down. Now we will go to the third bit. 37 and 49. When you take 37, children, can you get 37 in any table? You will not get. So what you will say, this 37 is a prime number. 137, that's all. So 37 is equal to 1 into 37. 49. 7 sevens are. So What are you getting in 49? 7 into 7. What is common to take, children? Actually, nothing is common means you can write 1, no? Here. So you can take HCF as 1. And what is LCM? 37 into 49. So multiply. 37 into 49. 9 7 63. 27. 33. 4 7 28. 12 to 14. So how much? 8, 11, 8, 1. So 1, 8, 1, 8 is the answer. So 1 is HCF, 1, 8, 1, 8 is LCM. I hope you have followed this, children. The next one is exercise. I'll take up exercise in the next class, children. I hope you have followed my class. Thank you, children. Bye. Children, there is a small mistake that I made here, children. I wrote 3 here but 8. It is 3 only. 1, 8, 1, 3. 1, 8, 1, 3 is the answer for this sum, children. So LCM is 1, 8, 1, 3. Please note it down, children. Thank you.